And what are we talking about? We are talking about polar form of a complex numbers. Now, we have seen how complex number can be represented in the Argand diagram. The next thing that we are going to expand on that. We are going to expand on that. And how are we going to do it? You remember me mentioning the angle? So we have an angle there. And we have a triangle kind of a figure. And the triangle is surrounded by a circle. From the center to this point here, that is the radius. And from this point here to that point, that is the x. And from that point to that point, that is y. So, we can see that x is equal to x component is equal to r cosine of theta. Let's say this angle is theta, and y is equal to r sine theta. Why are we saying y is equal to r sine theta? Because y is the vertical component of r, x is the horizontal component of r. Now, from your basic trigonometry, I think you can be able to picture that. Now, what are these trigonometric relationships useful? They are useful because we're going to use them in the polar representation of complex numbers. Now, let us briefly look at the derivations of this from the rectangular form, rather Cartesian form, to polar form of complex numbers. Now, if we all know that a polar form is in that nature, z is equal to x plus jy. Now, we've just seen also that x is equal to r cos theta, because r is the horizontal, x is the horizontal component. And we've also seen that y is equal to r sine theta. Now, substituting the values of x here and y, this cos, the sines, the r sines, and the x cos, we arrive at that. So, what have we done? We have just substituted the values of x and y in the coordinate, or rather the Cartesian form. Now, this can also be simplified further by representing it that way. Z is equal to r, the argument is theta. Now, what is theta? Now, from our basic trigonometry, if this is our triangle, and then that is y, let me draw it this way. If this is the triangle, this is y, this is x, then, and that is theta. Our tan theta, or theta, is tan inverse of y over x, opposite over the adjacent. So that is how we get theta. How do we get r? Okay, from the Pythagorean theorem, r is equal to square root of x squared plus y squared. That is the Pythagorean theorem. Now you can see that these concepts are related to the concepts that you already know. Pythagorean theorem, trigonometry, the Cartesian plane, and so on. Now, let us look at an example. But even before we look at an example, let us define these terms. What is R? R is called modulus or magnitude. The theta, that angle, is called argument. So we are going to represent these complex numbers as modulus and as argument. Let us see, look at one example. If Z is equal to 5 minus j10 is the Cartesian form. It can be written in the form, that form. We can write it in that form, and or in that. This is just a simple way of writing it, because this one is somehow lengthy. Now, we have to get theta and we have to get R. But before we get those particular numbers, we have to identify the x and y. So what is our x? Our x is equal to 5. And what is our y? Y is equal to -10. So let me use a pen here. This is our x, and that is our y. Y is not, we are saying -10 because you're taking the coefficient of j. So that is y is -10, not 10, -10. So that is why we already identified. Now we can now use the formulas theta, those formulas that we have looked at before. Say theta is tan inverse of y over x. Okay, so so that is theta. R is equal to the square root of x squared plus y squared. So using the formulas, you can see how they have been substituted. We have seen 5 squared plus R is equal to 5 squared, this 5 here, plus -10 squared, that one there, it results to 11.18. Now what is theta? Tan inverse of -10 over 5. So once again, the x, this is the x substitution, and this is the y. So y over x, tan inverse of y over x, is equal to -63.43. Now, there's something that is coming out here. Allow me to explain something else. Assuming that is the Cartesian plane, and that is a unit circle, I'll say that in that direction, the angles are positive. In that direction, let me use a different color so that in that direction, it is negative. So if the angle, we are seeing that our angle is -63.43, but we need an angle that is positive. So what are you going to see? It's negative somewhere here, -63.43. So it falls in the second quadrant. This is the first, this is the second, this is the third, and this is the fourth. So it falls in the second quadrant. So what is the positive angle? Just say 360 minus 63.43, and you get 296.6 degrees. So it has to be presented in as a positive angle. Now let us now see how it can be represented in a polar form. So that is the polar form. This is the R, this is the argument or theta, this is the argument or theta. It can also be represented just as simply as that, 11.18 and 296.6.